anybody shot, and we have not found the suspect. At 1:58 p.m., right about 1:58 p.m., the Houston Police Department received multiple calls of an active shooter on the second floor of Bentop.
4:51 a.m., Houston, Texas. Floodlights saturate the helipad of St. Marcellus Medical under sheeting rain. The wreck of a medevac helicopter lies broken across the east parapet, tail rotor twisted, cabin scorched. Containers marked as oxygen reserves line the perimeter. Inside, hazmat readings confirm crystallized narcotics precursors. 4 detainees kneel cuffed against the guardrail, surgical coats streaked with coolant residue. One is Dr. Selma Ortiz, Hospital Operations Chief. Another wears an airfield contractor badge. Nearby, DEA and FBI personnel unload evidence crates, each tagged with digital serials from the aircraft's manifest. Data on the recovered drive shows 7 unscheduled launches over 3 months. The press will call it a smuggling network disguised as emergency transport. For the command crews watching the monitors now, it is still a malfunction that should not exist. The aircraft had flown itself. 4:39 a.m., 15 minutes earlier. Rain runs off the floodlight housings, flashing white arcs onto the deck plates. A hospital helicopter spins idly on standby mode, rotor blur streaking the mist. 2 technicians in medical rain gear push stainless carts toward the cargo bay. Thermal cameras aboard a customs drone at 200 meters register excess heat around the sealed canisters. 42 degrees Celsius, too warm for oxygen. Command inside a mobile van on Travis Street cross-checks flight authorization. The code matches routine patient transfer, nothing unusual in the data. From a stairwell below, 6 agents ascend toward the pad, their movement tracked on body telemetry. Heart rates between 80 and 100. The lead agent signals readiness with a palm flick. Countdown 3 seconds. Lightning flashes across the city grid. The breach begins. 4:40 a.m. The door bursts open under pressure charge, splinters thrown across the tiles. Wind smashes through the gap, scattering loose paperwork from a rooftop station. Hands up, echoes in short bursts through the commnet. Rotor wash whips rain into horizontal bands. The technicians freeze mid-step, one dropping a tablet that skids against the railing. The helicopter's turbine whine builds beyond normal idle. On the command screens inside the van, the launch status still reads manual hold. The agents believe they are on time. They are not. Inside the cockpit, autopilot light already glows amber. Engine rotation climbs past 60% torque. A fuel pump somewhere in the maintenance sublevel kicks in with mechanical rhythm. None of it aligns with the team's timestamps. 4:41 a.m. Down below, the secondary entry group moves through a concrete corridor dripping with condensation. Their helmet cameras show pressure gauges lined in pairs along the wall. One agent twists a valve marked Feed Line 3. The gauge needle drops from 180 pounds per square inch to 0. Steam vents through a bleed port, temperature falling by 3 degrees per second. Confirmed, the operator calls. Hydraulics down. On the command display, rotor pressure falls. They think they've frozen the system. What they have closed is a decoy circuit. The true hydraulic loop runs inside a parallel pipe labeled as building coolant. In the overhead ductwork, vibration continues unchanged. The helicopter remains live, its internal clock advancing toward launch sequence while every observer sees it as disabled. 4:42 a.m. In the command van, Operator Lewis keys a manual override. Rain patters on the steel roof above, muffling voices. Screen flashes green. Sequence halted. Supervisors nod. Tension breaks for a moment. The operator logs the timestamp at 4:42:21. The data line confirms system compliance. On the pad, the aircraft sits motionless, blades slowing. or so the delayed feed shows. The true image, unseen, catches the rotor accelerating again, droplets cutting luminous rings in the air. The override tone that indicates success is itself generated by the same delayed loop. What command interprets as control is merely playback. Out the window, the rain's angle shifts, pushed by new turbulence. They do not connect the noise with the very machine they believe shut down. 04:43 a.m. The helicopter lurches against its tie-downs, skids scraping metal on concrete. Exhaust plumes turn the air opaque. A ground agent shouts into the radio, voice fragmented. Rotor live. Repeat. Live. Transmission breaks under wind noise. The aircraft's altitude climbs 1 meter, then 2. The crew scatter behind a stairwell bulkhead, floodlight glare flashing over their helmets. Lightning flickers, illuminating droplets suspended like dust. In the control van, the main screen turns white from static. The satellite link cuts. Operators assume weather loss. The takeoff data remains unseen until playback later, when they find the altimeter reading 75 feet. The machine departed under perfect parameters, route locked to an unlisted air corridor. No one had commanded it, yet every system logged authorization as complete. 4:46 a.m. The radar operators at Ellington Field watch a new blip emerge northeast of the city. The transponder broadcasts a valid medevac identifier, velocity climbing to 110 knots at 300 feet altitude. Storm bands scatter the return. Controllers interpret it as emergency diversion. Wind gusts measure 24 knots, heavy precipitation. They attempt voice contact. No response. Meanwhile, on the hospital roof, the lead assault team struggles to secure the canisters left behind. One bursts open under impact, releasing mist that crystallizes on the deck. Internal chemical sensors trigger alarms for unknown compound. Time of reaction recorded as 3 seconds from exposure. They retreat, sealing the pad with containment foam. The chemical plume drifts into the rain, faint blue under strobe light. 4:48 a.m. Inside the command truck, data relay stabilizes briefly. The aircraft's telemetry reappears. Pitch angle 8 degrees nose down, bearing 134. Command interprets this as descent. Orders issued to local air traffic control to guide it toward ground approach. The assumption holds until a customs drone overhead catches an image of rotor blades reflecting lightning, miles east of predicted position. GPS overlay reveals mismatch of 5 kilometers. They attempt a manual shutdown code transmitted via emergency channel. A green icon confirms receipt. No change in altitude. The flight continues steady. Autopilot reading route execute. Officers conclude that instrumentation error explains the false icon. Confidence restored momentarily. Each validation compounds the misread. 4:49 a.m. In the hospital's lower corridor, 2 technicians under arrest remain silent, their eyes fixed on the ventilation shaft humming above. Air temperature drops to 8 degrees Celsius. A faint vapor streams from a duct grill near the ceiling, drawn toward exhaust fans. The captured tablet, still active on the floor, displays coordinates in a repeating loop. Data analysts capture the feed. Numbers align with agricultural zones outside the city. Rainfall there heavy enough to dissolve particulate material within minutes. They suspect a scheduled drop, not yet comprehending that the dispersal has already begun via aerosol trace from the helicopter's undercarriage tanks. Every recorded variable fits inside normal range, so no alarm triggers. System logic favors continuity. 4:50 a.m. The aircraft pushes east through thick rain, altitude 400 feet, ground speed 120 knots. Sensors show gradual discharge through the ventral ports, chemical mist blending with stormwater. On the control van's map, the flight path stabilizes, then abruptly ends. The transponder shuts down automatically at coordinate 29.652 north, 95.014 west. Operators misread this as crash signature. Orders issued to initiate search grid. 20 minutes later, a debris field is found, but only from detached tail fairing. The rest of the frame lands intact 8 kilometers away, empty tanks still steaming. No pilot, no crew, no power signatures remaining. The system completed its programmed route and then executed self-disconnect. 4:51 a.m. now loops on every monitor as evidence timestamp. Rain continues over the hospital, pooling around the remains of the first aircraft. Agents record residue samples, pH 5.1, temperature -2 degrees at core. Each barrel lifted into containment. The detainees are transferred under armed guard to federal custody. Wind gusts carry faint chemical odor down Fannin Street, measured concentration 0.03 parts per million. On the command van's central screen, a digital clock resets for system analysis. A technician notices power draw steady at 0.8 amps from a non-essential circuit. It traces back to the hospital's logistics bay, 1 floor below record storage. Circuit name, Air Dispatch Node, the same term appearing in the seized tablet. 5:10 a.m. Cyber specialists access the hospital's control network through a fiber uplink. Code maps show scheduled operations under medical logistics, but with flight references embedded inside prescription shipments. The timestamps align perfectly with each helicopter dispatch over the last quarter. Rain intensity decreases to 7 millimeters per hour. A generator hum fills the background. Analysts attempt to disable the process, but find permissions routed to an off-site administrator credential, linked to a pharmaceutical supplier in New Orleans. That link remains active. A digital pulse shows next dispatch scheduled in 47 minutes. The same automation that caused the crash is preparing again. 5:15 a.m. Crews on the rooftop resecure the perimeter. Helicopter fragments loaded into sealed trucks, barcoded individually. Airspeed sensors from the wreck record mechanical function normal until loss of signal. Nothing suggests sabotage. Investigators debate whether to ground all hospital flights in the region. Decision delayed pending confirmation. From the lower levels, hum of refrigerant compressors continues without authorization. Thermographic scan reveals heat concentration under the morgue ramp. Agents move to inspect. Behind an access panel, they find a secondary conduit branching toward the exterior elevator shaft. Cable thickness consistent with hydraulic control lines, not electrical. Pressure gauge reads 70 pounds per square inch and rising. It leads straight up to the helipad, feeding a pad that now stands empty. 5:18 a.m. Command realizes the pad is refilling. Fluid seeps through drainage slots, forming a thin reflective film. It smells faintly of ethanol. Sensors mark vapor density increasing at 0.2% per second. Wind shifts from west to southeast. The next scheduled dispatch now less than 40 minutes away. Operators scramble to isolate building power. Manual breakers trip. Lights flicker. Still, the flow persists. Backup generator re-engages automatically to preserve hospital critical systems. The automation that protects patients also preserves the mechanism fueling illicit launches. The attempt to stop the machine sustains it instead. 5:25 a.m. A final order. Cut total power. Fire crews disconnect external grid supply. Voltage drops to 0 across most circuits. Yet the helipad surface still hums faintly under rain impact, vibration from residual hydraulic pressure. Thermal imaging confirms remaining heat signature 32 degrees Celsius at center ring. The flight protocol, cued hours earlier, waits only for threshold voltage to restart. Command cannot destroy it without shutting down hospital life support. Decision suspended. The system remains armed. 6 a.m. Daylight breaks gray through low clouds. Federal agents finish initial sweep. 31 barrels sealed, total weight 2 tons, each tagged and logged. Dr. Ortiz transferred to armored transport at 6:04. She speaks once. It's still scheduled. No one answers. Downstairs, servers reboot under emergency power, unmonitored. Cooling fans spin back to operational speed. One node shows data transfer to a remote address, bandwidth negligible, but continuous. Energy draw 0.8 amps, the same value noted before. The raid's apparent success stands recorded. Aircraft recovered, suspects detained, materials seized. Yet sensors still register faint electromagnetic rhythm through the conduits below. 6:32 a.m. Analysts verify nationwide flight control logs. Several hospitals report transient spikes in auxiliary grid use matching the same pattern. All correspond to facilities within the same procurement network as St. Marcellus. The realization forms quietly across command terminals. The operation did not uncover an isolated breach, but an architecture. Every reading that had seemed unique now repeats elsewhere. Time shifted by precisely 48 hours. The control logic was distributed, resilient, self-correcting. 7 a.m. Rain thins to drizzle. Cleanup crews roll foam carts across the pad, temperature steady at 9 degrees Celsius. The city below resumes early traffic. On the command van's final screen, the replay shows the helicopter lifting clean into the storm. Every sequence valid, every parameter green. Only the meaning was wrong. The machine had never been stolen. It had been built to obey a different master clock. The system continues to pulse faintly underground, waiting for the next scheduled dispatch. No one disconnects it. The hum fades into background power noise, indistinguishable from normal hospital rhythm. The operation ends recorded as success. The network remains alive, quiet, on time.